welcome to my channel. My name is Karthik and this will be the first of the many videos on the topic of Hadoop administration and operations. Now this course is for anyone who wants to understand the core concepts and working principles of a Hadoop ecosystem. Now I have designed this course specifically for people who are new to this field, and hence I'll try to be as descriptive as possible when I'm explaining things. Now this might be a little frustrating for those of you who already know the basics or have already been working in this field. However, we will be covering some really important topics over the series, and I can assure you that by the end of this course, you will be having a detailed insight into the working of a Hadoop ecosystem. Now, as a prerequisite, it would be better if you have the basic knowledge of the Linux operating system. This is because we will be performing all our demos on a CentOS Linux machine. Now, Hadoop usually runs on top of a Linux operating system, and hence administration and operation of Hadoop is somewhat closely linked to Linux. But don't worry, you don't need to be an expert, just the basic knowledge would be fine. Also, I'll try to cover the Linux concepts as well wherever I feel necessary. Now moving on. Today will be an introductory class where I'll give you an introduction into what big data is, where Hadoop fits in all this, and then we'll briefly discuss about the various distributions of Hadoop that are available in the market. Now I would be really surprised if you haven't heard about big data in some or the other way. Today we hear about big data almost everywhere. So the question you must ask is, what is this big data? Data has always been there. Also, there are some robust database technologies out there. There is nothing new about data. Then why is there a sudden need for this new classification of data which we call as big data? Well, to answer that question, yes, it is true that data has always been there. But the thing that has changed is the scale at which we are generating it today. Today we generate more data in a single day than what we used to generate in a year, a decade ago. The millions of photos, feeds, videos, tweets, bank transactions, stock transactions, sensor data, email data, etc. has to be stored somewhere. Also, according to some estimates, 80% of the data generated is unstructured, which means they don't have a defined pattern, or in database terms, they don't have a defined schema. In simpler words, they are not in the form of rows and columns that you see in a spreadsheet. Now the industries soon realized the treasure of information that could be unlocked if they could somehow devise the capabilities to analyze these huge dumps of data. Be it business strategy, marketing trends, tactical military decisions, healthcare and scientific breakthrough, all this can be achieved if the industries could somehow effectively store and process these huge dumps of data. Mukesh Ambani, the famous petroleum tycoon, once rightly said, "Data is the new oil." However, this is where the limitations of traditional database systems became evident. These systems were not able to effectively manage or process data at this scale. Hence, it was seen as necessary to define a new term, big data, which refers to data that is so large and so complex that traditional data processing systems became inadequate to deal with them. Now you might ask how big a dataset should be to be qualified as big data. Well, to be frank, there is no definitive answer for that. There is no hard limit that defines big data. It depends more on perception and hence can differ from enterprise to enterprise on what qualifies as big data. If you, as the owner of a company, feel that your traditional systems are unable to deliver the results that you want with the kind of data that you are dealing with, you can take a call to implement big data technologies. However, a different company dealing with the same kind of data might not necessarily feel the same way. Now that you all understand big data, let us now discuss what Hadoop is and where it fits in all this. Once the problem of big data was known to everybody, there was a revolution of big data technologies. One of the earliest responders was Google, which was also one of the first companies to face the challenge of managing and processing huge datasets for their search engine. Now Google came up with the first ever implementation of the idea of distributed storage and parallel processing by publishing two important papers, the Google File System in 2003, followed by MapReduce in 2004. Based on the insights from these two papers, Doug Cutting along with his partner Mike Caffarella co-developed an open source distributed computing platform for their web crawler project called Nudge. At that time, they were developing it for the open source Apache Software Foundation. Doug later went on to join Yahoo, with whose help he took out and developed parts from his earlier project to create Hadoop. Interestingly, Doug took this name from his 2-year-old son, who used to call his beloved yellow elephant Hadoop. The yellow elephant also went on to become the official logo of Hadoop. Soon many companies started adopting Hadoop, and seeing its effectiveness in dealing with big data, a bunch of other projects started to develop around it. Today, Hadoop is at the center of this big data technology revolution. As Doug said in one of his interviews, today Hadoop has become like a kernel or an operating system for big data and provides a core platform for other big data applications. Now, Hadoop can be summarized as a framework of tools and applications that work together for distributed storage and parallel processing of data at the scale and complexity of big data. Now let me list out some of the important characteristics of Hadoop. Hadoop is designed to be highly flexible, scalable, and a fault-tolerant system. Hadoop is extremely cost-effective. It has comparatively lower storage cost per TB. Unlike traditional database management systems, Hadoop can effectively deal with semi-structured as well as unstructured data. Finally, Hadoop is extremely effective in faster processing of huge amounts of data. Now, even though Doug created Hadoop while he was in partnership with Yahoo, he made it as an open source software under the Apache Software Foundation. Apache Hadoop became the open source distribution for the Hadoop framework. However, since then, many vendors have stepped in to create their own flavor or distributions of Hadoop. Now, these three are the most well-known distributions of Hadoop in the market. Cloudera is considered the leader with respect to its market share and market penetration in the Hadoop market space. It was formed in 2008 by 3 engineers from Google, Yahoo, and Facebook. Doug Cutting joined the company in 2009 and is currently its chief architect. Hortonworks was formed in 2011 and has been fast growing since then. It is expected to be a big player in the coming years. At their core, both Cloudera and Hortonworks have been built upon Apache Hadoop. They have borrowed their Hadoop source code directly from the Apache Hadoop project and have built their enterprise distribution on top of it. Now, Cloudera has built some of its own proprietary applications. However, both Cloudera and Hortonworks do contribute back to the Apache Hadoop open source community in the form of new Hadoop applications and patches. Now, Hortonworks is a totally open source distribution. They distribute their data platform in the form of unmodified code directly from Apache. MapR, on the other hand, is in many ways different from the other two. MapR has rewritten major portion of the core source code to create somewhat their own proprietary enterprise product. Now here are few more of the known distributions of Hadoop. Any corporate enterprise would go with one of these distributions instead of deploying Apache Hadoop in its original form. This is because the Hadoop platform is made up of several interdependent components, and installing and configuring each one of them can sometimes become notoriously complicated on big production clusters. This is where these distributions come into picture, which take away the complexities of managing separate elements of Hadoop by distributing the various components in the form of a single package or product. This ensures that all the various components in a single package would be of the correct version, and their configurations are tried and tested beforehand to ensure they work properly. These distributions also provide production support, which we all know is extremely critical for any corporate level deployment. Now we have reached the end of session 1. In the next session, we will be discussing a few differences between the traditional database systems and Hadoop. Don't forget to like, share and subscribe. See you next time.